Hi everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is the Probability and Statistics 1 for May-June 2021, and the code is 9709/51. Okay, so let's move on to question number 1. Question number 1. A bag contains 12 marbles, each of different size. 8 of the marbles are red and 4 of the marbles are blue. How many different selections of 5 marbles contain at least 4 marbles of the same color? Okay, basically from here I would say there are 8 red marbles and 4 blue marbles, and we are taking 5. Okay, so from here you should get at least 4 marbles with the same color. That means this could be 4 blue, 1 red, or 4 red, 1 blue, or I will get 5 red. Okay, because at least 4 marbles with the same color. So now, since we need to find the different selections, all right, how many different selections means that here I will say to get 4B, 1R, initially you have 4B and 8R. Therefore, this number of selections, it will be combination. Okay, so it will be 4B, choose 4B, right? From 4B you choose 4, so that means this is 4, choose 4. Now to make it to 5 marbles, right, we need to follow by choosing another one red marble from 8 red marbles. That means it will be times 8C1, times because of we are performing second task. When you see all, right, this all means plus. Okay, so plus with, to get 4R, I need to choose the 4R from the 8R. Therefore, it will be 8C4. Followed by means times, choose 1B from 4B. So 4, choose 1. Okay, and the next combination is all 5 red. 5 red means that I have 8 red, then you choose 5. So it will be 8C5. Okay, so from the first calculation it will be 8, and the second calculation it will be 280, last calculation it will be 56. Then the total of all these three values, it will be 344. Okay, so it means that we have 344 selections to choose the 5 marbles that contain at least 4 marbles with the same color. So with this we have solved number 1. Okay, question number 2. A company produces a particular type of metal rod. The lengths of these rods are normally distributed with mean 25.2 cm and standard deviation 0.4 cm. A random sample of 500 of these rods is chosen. How many rods in this sample would you expect to have a length that is within 0.5 cm of the mean length? Okay, so first of all, I will write X is normally distributed with mean 25.2 and standard deviation 0.4. So we always write down the variance, therefore I square the 0.4. And then from here is given that n is 500, that is a sample size 500. And now before you get how many rods in this sample out of this 500 which has the length within 0.5 cm of the mean, is compulsory for us to count the probability for the rod that has the length between within 0.5 cm of the length first. Therefore, now when you refer to the diagram here, we know that it is 25.2, this is a mean. So if it is within 0.5 cm means that here is 0.5 cm. Okay, and same goes to the right side, it will be 0.5 cm. So now if 25.2 minus 0.5, you can say it is 24.7, and when 25.2 plus 0.5, it will be 25.7. Okay, so that means I'm counting probability that the X in between 24.7 or and 25.7. If you don't want to use this calculation, probably you can just write X is between negative 0.5 and positive 0.5. But this is, sorry, this should be x minus mu. Okay, because that's the 0.5 centimeter from the mean. So you can use this, the first form or the second form. So I will be using the second form. Okay, so then from here, I will just standardize the normal random variable. So when we need to standardize, your x is normally distributed with mean, mu, variance, sigma squared. The standardized normal random variable is a z, which is x minus mu over sigma. Okay, this is the formula that will be used in this question. So which means now I have to standardize it. Therefore, 24.7 minus the mean 25.2 over standard deviation is 0.4 because this is sigma squared. So here over 0.4 and less than z less than 25.7 minus 25.2 over 0.4. Okay, so when you do the calculation, the first value is going to be negative 1.25 and the second value is 1.25. Alright, so now I need to solve this probability. So to solve the probability of z between two values, so then we have to sketch a graph. Now, this is a bell-shaped curve and the middle value is 0. It is symmetrical as z equals to 0. And now mark these 2 points, 1.25 and positive negative 1.25. So draw these two lines, okay? Then now your region is bounded by these two boundaries. That means this is our region. So from here, I will say that the region from 0 to negative 1.25, this red color can be flipped to the right side. Okay, so when I flip it to the right side, it becomes double of 0 to 1.25 because it is symmetrical. That means I will be using double of 0 to 1.25 to get the total region here. For your information, probability between under the curve is the area of the region. Okay, so from here I will say it is double of probability z between 0 and 1.25. Now, when you refer to the table, okay, we always use less than. So that means in order to get the green region, it will be Pz less than 1.25 minus Pz less than 0. Then I will be getting the green region. So that means here is going to be double of Pz less than 1.25 minus Pz less than 0. Then from the formula table, right, then you can get the normal table. You can get the first probability will be 0.8944 and then the second probability is 0.5. Then now when you simplify, this is going to be 0.7888. Now for your information, the question is asking for how many rows out of the 500 which has this interval, right, of the length. So now this probability is not the final answer yet, therefore I give more than 3 significant figures and then followed by a number of rows. It will be 500 because 0.7888, this is the probability for one row that has the length within 0.5 centimeter from the mean. Okay, so now the number of rows out of the 500 rows in the sample, it will be 500 times 0.7888. So then you will be getting 394.4. And then from here, I can round up to 3 significant figures as my final answer. So it will be approximate to 394. Okay, so this is the solution for question 2. Now for the next question, question 3a. How many different arrangements are there of the 8 letters in the word released? Okay, so release, there are 8 letters. But out of 8 letters, I have 3 E's. Okay, and the rest are all different letters. So from here, since we are arranging all 8 letters, therefore we are going to use the factorial method. So the number of arrangements is going to be 8 factorial, but if you just write 8 factorial means that you are given 8 different letters. So now since we have 3 e's, therefore you have to divide by 3 factorial. Okay, so the answer will be 6720. So this will be the number of arrangements when you arrange 8 letters. Okay, now for B, how many different arrangements are there of the 8 letters in the word released in which the letters LED appear together in that order? Okay, so now I have LED, but must be in this order. And we have total of 8 letters. LED already consists of 3 letters. Take up 3 letters, that means we have another 5 letters. Okay, but out of these 5 letters, I have 2 E's. Right? So from here, I will say, now it's mentioned that this LED, these 3 letters must be in this order, must be in this particular order. That means now what we need to do is I'm arranging 1 and plus this 5, it will be 6 letters in total. Okay, so I will write number of arrangements. I will have to arrange 6 letters. Okay, but of course this LED can be in any places. So we have, it can be first, second, third, fourth, fifth, and sixth. Therefore, I will just treat the LED as 1 letter, then 1 letter together with the rest of the 5 letters, it will be 6 letters. But if you just write 6 letters, means that these 6 are different letters, which is not correct because out of the 5, we still have the 2 E's here. Therefore, have to divide by 2E. Okay, then at last you'll be getting 360 arrangements. For the part C, an arrangement of the 8 letters in the word released is chosen at random. Find the probability that the letters A and D are not together. Okay, so to get the probability, we know that probability is like PA equals to NA over NS, right? So this NS is the number of arrangements without the restriction, and the NA will be satisfying this condition. So this is just a guideline, right? So probably I will just use another color as a rough work. So PA is NA over NS. Now I need to find out how many arrangements that satisfy this condition. So it means that A and D are not together, which means now I will have R, E, okay, L, E, A and D I exclude first, then here as E. So then from here I have to arrange these 6 letters, which means my probability equals to the NA. The NA is to arrange these 6 letters first. That will be 6 factorial. But out of 6 letters, I have 3 E's. So divide by 3 factorial. Then now, where to get the A and D? So my A and D can be in any of 2 slots here. Okay. So then it will be 1, 2, 3, 4, 5, 6, 7. So I have 7 slots for the A and D. So now I have to arrange them. Therefore, out of 7, I will permutate 2. Means that probably I choose the first 2. Then after that, the first one can be A, the second D, or the first one can be D, or the second is A. That's why I'm using 7P2 here. So with this, that is the arrangements for the 8 letters such that A and D are not together. Okay, but since we are counting probability, don't forget to divide by the NS. NS means the number of arrangements without restriction, which is the part A answer. Okay, because in the part A, it is just the number of arrangements without any restriction. So I will just copy 6720 in my as my denominator in this part C. Okay, so from here, when you calculate the numerator, it will be 5040. Then denominator, I will just remain as 6720. And at last, you will be getting 3/4, or you can just write 0.75 as the probability for part C. Okay, now for question number 4. To gain a place at a science college, students first have to pass a written test and then a practical test. Each student is allowed a maximum of 2 attempts at the written test. A student is only allowed a second attempt if they fail the first attempt. No student is allowed more than 1 attempt at the practical test. So practical test only 1 attempt. If a student fails both attempts at the written test, then they cannot attempt the practical test. Alright. So if fail both, then cannot proceed to the practical test. Now, the probability that a student will pass the written test at the first attempt is 0.8. If the student fails the first attempt at the written test, the probability that they will pass at the second attempt is 0.6. And then the probability that the student will pass the practical test is always 0.3. Now A, draw a tree diagram to represent this information, showing the probabilities on the branches. Okay, so now here, the tree diagram will be, this is the written test 1. Okay, then this is the written test 2. And then after that, practical test. Now, a student either pass or fail. So pass or fail the written test 1. So it's mentioned that the student will pass the written test at first attempt is 0.8. So it means that here is 0.8 and fail is 0.2. Now, when the student fails the first attempt, then he will pass, or they will pass the second attempt at 0.6. That means this is failed. So here, pass the second attempt at 0.6. Therefore, fail the second attempt will be at 0.4. Now, the probability that the student will pass the practical test is 0.3. Now, when you refer to the question, okay, a student is allowed, here. The student first has to pass a written test and then practical test. So it means that once the student has passed either the test 1, written test 1 or written test 2, then he will proceed to practical test. And the probability of passing practical test is always 0.3, which means if the student has passed written test 1, then from here, right, the student can proceed to practical test directly with probability, with passing the test, the practical test at 0.3. Okay, so probably I draw like this. So here is going to be 0.3 and fail the practical test at 0.7 because it's mentioned always 0.3. Then same goes to the student who has failed the first written test and then he passed the second written test, then he can go for the practical test. Again, passing rate is 0.3 and the failing rate is 0.7. Okay, but if the student fail both, if the student fails both attempts at the written test, then he cannot attempt the practical test. So this is the tree diagram. Alright, so now B, find the probability that a randomly chosen student will succeed in gaining a place at the college, which means the student will pass the written test and the practical test. Right? So from here, written test pass and practical test pass, or written test 1 fail but then pass the written test 2 and pass the practical test. So this will be the probability that the student will get the place at the college. Okay, so now my probability is basically pass the test 1, the written test 1, 0.8, and pass the practical test, 0.3. So it will be 0.8 times 0.3, or is plus, fail the first written test, which is 0.2, and then pass the second written test, which is 0.4, and then at last pass the practical test. Okay, so the first calculation will be 0.24, and the next calculation is going to be 0.036. So at last you will be getting 0.276. So this is the working for this part B. Now for part C, find the probability that a randomly chosen student passes the written test at the first attempt, given that the student succeeds in gaining a place at the college. Okay, so it means that when you see given that, this is the conditional probability. So I will write P pass written test 1, okay, because of first attempt, given that the student get the place. So gain a place. Alright, so according to the conditional probability formula, PA/B is going to be PA intersect B over PB. Okay, so from here, I will be getting P pass written test 1 intersect means N, gain a place over probability that the student gain a place, means pass the written test and also the practical test. So pass written test 1 and gain the place. That is the first case. Okay, that means that will be pass the written test 1 and pass the practical test, which means it's 0.8 times 0.3. Then I will be getting 0.8 times 0.3 divided by probability of gaining a place at the college, means that the student pass, right, which is the part B. Okay, we have found it. So 0.276. So this is 0.276. Then now I will be getting 0.24 divided by 0.276. At last, you will be getting 20 over 23, or you can leave your answer in decimal, which is 0.870, correct to 3 significant figures. So this is the solution for part C. Okay, now for question number 5. The times taken by 200 players to solve the computer puzzle are summarized in the following table. So you are given the time in seconds and the number of players, but we know that total is 200. Draw a histogram to represent this information. So to draw the histogram, first of all, we have to check the class width. Okay, so from here, class width is 10 because the average, the upper boundary is 10, which is the average of these two numbers. Then when you look at the rest of the classes, the previous one, the upper boundary for the previous class is supposed to be 0. So it means that the class width here is 10. Then 20 minus 10 is also 10, but 40 minus 20 is 20. Therefore, due to unequal class width, we need to calculate the frequency density, which means, right, I have to redraw this table and then add on 2 values, right? So I need to add on 2 calculations. So this is the time T, this is number of players. Then I have to calculate the class width, which is a C. Then this is frequency density, which is F over C. Okay, so for the first one, it will be 10. Then for the second class, it will be 10 as well, because when you minus here, it's just 10. Okay, then 20 to 40, the class width is 20. Because 40 minus 20, I get 20 over here. So 40 to 60, again, it is 20, the class width. Then 60 to 100, it will be 40. Okay, so now for the frequency density, it is frequency over class width. So F over C. So I will get 16 over 10, it will be 1.6. 54 over 10, it will be 5.4. 78 over 20, it will be 3.9. 32 over 20 is 1.6. 20 over 40 is 0.5. Okay, so my histogram will be class boundaries, which is here, or this will be the class boundaries and also the class limits. Okay, class boundaries on the x-axis, on the horizontal axis, and the frequency density on the vertical axis. So from here, I know that my vertical axis maximum is 5.6, minimum is 0.5. All right, so and then my horizontal axis, I have to include up to 100. So by looking at this graph, it will be 24. Okay, I will let this be 20. This is 20. Here 40, 60, 80, 100. Okay, then this is going to be time. And then I need 5.4. So it will be 6. That means it's 1, 2, 3, 4, 5, 6. This will be my frequency density. Okay, so probably here I can write frequency density. Okay, so now when 0 to 10 is 1.6. So 1.6 here is 0. So 0 to 10 here is going to be 10. 1.6 here is 1. That means here is 1.5. So 1.6 is somewhere here. Right. So when you draw, please use ruler so that it is a straight line. Okay, so now the second histogram, the second bar is 10 to 20. The height is 5.4. So 10 to 25.4 is somewhere here. So draw the straight lines. Okay, so now the next is 20 to 40, it will be 3.9. So 20 to 40, 3.9. Okay. Then the next is going to be 40 to 60, 1.6. 1.6. Okay, lastly, 60 to 100, it will be 0.5. 60 to 100, 0.5. Alright, so this is the histogram. Okay, now B, calculate an estimate of the mean time taken by these 200 players. Okay, so when we need to count the mean, okay, then the mean is basically summation Fm over summation F, whereby the M here is the midpoint. Okay, all the midpoints. Alright, so now means that I have to calculate the midpoints first. So I'm going to write midpoints M, this is the F. So how do we count the midpoint? It's basically the average of the class limits. Means that you get the average of these two values, you plus together and divide by 2. So it will be 5 and so on. Okay, so I will just write down all the calculations. It will be 5, then 15, after that 30, 50, and 80. Okay, how to get the 80? 60 plus 100 is 160. So 160 divided by 2, it will be 80. That is the M. Then the F, I will just copy the number of players. It will be 16, 54, 78, 32, and 20. Okay, so from here, our mean is summation Fm over summation F, which means now you need to multiply. That is the Fm. Then you get the total. Right. So here will be 5 times 16 plus 15 times 54 plus 30 times 78 plus 50 times 32 plus 80 times 20 over the total F. We know that total is F is going to be 200. Right? Then from here, you will get 6430 over 200. And at last, it will be 32.15. And now I round up to 3 significant figures. It will be 32.2. So that is our mean. Okay, C. Find the greatest possible value of the interquartile range of these times. So now, for the interquartile range, we need to get the cumulative frequency. Okay, therefore, I will just copy the table. This is the T, 0 to 10, then 10 to 20. The rest will be with the width of 20, if you still remember that. First two, next two will be 20, then the last one will be 40. Okay, then for the F, refer back to the previous table, 16, 54, 78, 32, and 20. Just rewrite. Then now I need to get the capital F, which is the cumulative frequency. So The cumulative frequency is counted by adding the previous total, okay, and the existing f. So this is 16. So then this 16 you plus with 54, and that is my next capital F. That will be 70. Alright, so 70 plus 78, it will be 148. 148 plus 32, it will be 180. 180 plus 20, 200. Okay, so interquartile range is basically Q3 minus Q1. This is Q3 minus Q1. So now I need to get the class first. So from here, Q1 is the 1/4 of the total value. So that means we have 200 in total, 200 data in total. Therefore, 200 times 1/4, it will be 50th, right? So when you look at here, 50th means that the first class will contain 1 to 16 player, right? I mean the time taken by 1 to 16 players. Then the second class will be including data number 17 until 70. That means now our data is 50, therefore it will be in the second class. So I will classify this as Q1 class. So same goes to Q3. Q3 is 3/4 of total. That means this is going to be 150, the position, okay? So the Q3 class is going to be 150, means that it will be in the 40 to 60. So now in order to get greatest possible interquartile range, so now greatest interquartile range, I will write IQR. That will be Q3 minus Q1. But then in order to get the greatest IQR, okay, I have to take the biggest, which is 60, then minus the smallest in the Q1. So I use the greatest Q3 value minus the lowest Q1 value. That means it's 60 minus 10. Then you will be getting 50. So this will be the greatest interquartile range. Now, next question. In Questa, 60% of the adults travel to work by car. A random sample of 12 adults is taken. Find the probability that the number who travel to work by car is less than 10. So from here, we know that travel to work by car is success. And then you are considering adults. That means this is binomial distribution. Okay, so your X is binomial distributed with N is 12, and then the P is probably a success. 60% of the adults travel to work by car. That means this is the P. So here's 0.6. And now you need to count probability that number of adults is less than 10. So P X less than 10. Okay, now for your information, when the X is binomial distributed with NP, probability that X equals to small x, it will be NCX. The C is a combination here. P power X, Q power N minus X. Right, so when X less than 10, it will be 0, X equals to 0 until 9. So you have to calculate a lot. Therefore, instead of calculating X equals to 0, 1 until 9, 10, 11, 12, all this, right, I would say I use total 1 minus 10, 11, and 12. That will be less than 10. Okay, so I'm using this concept now. So it will be 1 minus px equals to 10 plus px equals to 11 plus px equals to 12. Okay, then here will be 1 minus, the formula is NCX, so 12C10, the P is 0.6, degree 10, and then Q is 0.4, degree 2. Right, P is 0.6. That means the Q is 1 minus 0.6, which is 0.4. Q is 1 minus P. Plus 10C11, 0.6 degree 11, 0.4 degree 1. And then plus 12, sorry, not 10, it's 12C11. 12C12. Okay, when 12C12, you can just ignore it because it will be same as 1. That means now you have 12 successors, which is 0.6 to the power of 12. Okay, I will just write here. So when you do calculation, this is going to be 1 minus 0.06385 plus 0.01741 plus 2.17678 multiplied with 10 power negative 3. So it's a small value for the last probability. So from here I will get 1 minus 0.08344, and then you will be getting 0.91656, and when you round up this value into 3 significant figures, it will be 0.917. So this is how we calculate the probability when you need to consider a lot, right? I will just use total probabilities minus the extra, right? So this is the solution for the part A. Now for part B, a random sample of 150 adults is taken. Use an approximation to find the probability that the number who travel by car is less than 81. Okay, so from here, your N is 150. Again, our P remains as 0.6. So when you calculate the NP, it will be 150 times 0.6. I will be getting 90. And then the NPQ is going to be 90 for my NP, then times my Q. That means the Q is 0.4. So when you times by 0.4, this is going to be 36. So now, since your NP and NQ are greater than 5, therefore, we need to apply the approximation, which is normal approximation to binomial. Okay, so the working becomes X is binomial distributed, 150 as the N, probability P is 0.6, and now I approximate to normal, which is the variable is W, and then the mean is 90, and then the variance is 36, because our formula is X is N mu sigma squared. Okay, so now I need to count which is less than 81. So Px less than 81. But then since we have approximated it to normal distribution, that means it's compulsory to consider the continuity correction. So less than 81, it will be 80, 79, and so on. All these are my X values. But then for the continuity correction, you are just allowed to plus minus 0.5 from 81. That means it will be either 80.5 or 81.5. So now I will just copy this less than, but I change the X to W, then less than. Now in order to include all these ticks, I should choose less than 80.5. Okay, then from here, once I have converted it to W, that means I have to refer to the normal distribution, which means now I need to standardize it. Okay, so my working becomes PZ less than 80.5 minus the mean is 90 over here, then over standard deviation 6. So I will write minus 90 over square root 36, or you can just write over 6, no problem. Then from here, you will be getting z less than negative 1.583. Now again, once you have standardized it, sketch the graph. So now I mark negative 1.583, and then the region is less than. Less than means towards the left hand side. Okay, but then when you refer to the graph, our region always positive. That means now you need to reflect. Okay, instead of here, or probably I will just draw it on the same diagram. So I will flip it to the right side so that the critical value is positive. Right? So instead of calculating the blue region, now I'm calculating the orange region. So the orange region is basically 1 minus PZ less than 1.583. Okay? So then my working becomes 1 minus PZ less than 1.583. And now read this probability from the table. So it will be 1 minus 0.9433. And at last, it will be 0.0567. Okay, so this is the solution for part B. Now, part C, justify the use of your approximation in part B. So you can just write NP is 90, NQ is 150 times 0.4, which is 60. So since NP greater than 5 and NQ greater than 5, hence normal approximation to binomial. Okay, so that's the justification. Now question 7. Sharma knows that she has 3 tins of carrots, 2 tins of peas, and 2 tins of sweet corn in her cupboard. All the tins are the same shape and size, but the labels have all been removed. So Sharma does not know what each tin contains. Sharma wants carrots for her meal, and she starts opening the tins one at a time, chosen randomly until she opens a tin of carrots. The random variable x is the number of tins that she needs to open. Now show that px equals to 3 equals to 6 over 35. So initially I will write 3c, okay, c for carrots, and then 2e, e for peas, and then 2 tins of sweets, so 2w. Right now, obviously, to solve this question, or obviously this question belongs to geometric distribution. Okay, this is geometric. Right, because you need to open the tins until she gets the tins of carrots. So now when px equals to 3 means that she has to open the third, or yeah, she will get the tin of carrots, the first tin of carrots on the third tin. Right, so that means x equals to 3 means that first 2 are not carrot tins, and the last one is a carrot tins. Okay, so when px equals to 3, now non-carrot, so from here non-carrot means that it will be 4 out of 7, because 3 plus 2 plus 2 is 7. Now after you have opened up first tin, total left 6. Okay, so the non-carrot tins at first 4, so 4 minus 1 becomes 3. And then after she has opened 2 tins, then now at first 7, here total 7. So 7 minus 2 left 5 tins. And now this tin must be carrot, means that there will be 3 carrot tins here. So this will be the probability, and now when you simplify, this is going to be 6 over 35. Okay, so this is how we prove the probability. Now B, draw up the probability distribution table for x. So now I will say px equals to 1. When she opens the first can, she got the tins of carrot. That means initially it will be 3 carrot tins out of 7. So the probability is 3 over 7. Right? So now, it can be she has to open up to second tin. Then only she got the caret tin. So which means the first tin is not caret and the second tin is caret. So from here, first tin is not caret means that it will be 4 over 7 because we have done it in previous calculation. So 4 over 7. And then still have 6 more left, but out of 6 tins, 3 are carets. So from here, you will get 2 over 7. Okay, now px goes to 3 already found. It is over 35. So you can either leave your answer in over 35 or just leave it in the simplest form. So better I change to over 35. So that means this one you times 5, then it will be 15 over 35. And the next calculation is going to be 10 over 35. So when px goes to 3 is counted, then I will just write down first 6 over 35. This is from A. Then now when px goes to 4. When px goes to 4 means that it will be first 3 are not caret tin, then the last one is a caret tin. So that means at first it will be 4 over 7. Then it will be 3 over 6 because you have 4 tins of non-caret. Then it will be 2 over 5 non-caret and then left 4. But out of 4, don't forget, you have 3 caret tins. That means this is going to be 3. Okay, so when you simplify all this, it will be 3 over 35. Now, since we know that there are 4 non-caret tins, that means it could be open up all these 4 non-caret tins, then only she got the first caret tins, right? That means she might need to open 5 tins. So which means this will be P. First 4 are non-caret tins, and then the last one is a caret tins. So which means I will get 4 out of 7. Okay, just copy the first 3 probabilities from the previous calculation. Then after she has opened up 3 non-caret tins, then left 4 and 1 non-caret tin left. Okay, and then 3 caret tins left now, it will be 3 over 3 because out of 7, right, all this open up already. That means you still have 3 out of 3 for 3 out of 3 for the caret tin, which is 1 over 35. Okay, so from here I will just put them in a table. So this is the x values, px equals to small x. So the x will be 1, 2, 3, 4, and 5. So just copy all this and put them in the table. So the first one is 15 over 35. The second is 10 over 35. Then 6 over 35. 3 over 35. And lastly 1 over 35. So you can double check your calculation. Make sure the total of all the probabilities are 1. So you can just get the total here. There will be 1. Okay, then your table is correct. Now, part C, find variance x. Okay, so when we need to find variance x, we have to use back this table. Okay, so variance x formula is basically ex squared minus square of ex. So the ex is the expected value. So now I have to count the ex first. So ex is basically summation xp. Right, that means x multiplied with p, then you get the total, which means it's basically just multiply first and then you total up. Okay, so I will write 1 times 15 over 35 plus 2 times 10 over 35 plus 3 times 6 over 35 plus 4 times 3 over 35 and 1 over 35. Okay, so 3 over 35 and 1 over 35. Alright, so when you get the total, this is going to be 70 over 35, which is same as 2. So now for the EX squared, I've shown here. So EX squared means it is same as summation x squared times the probability, which means now you need to square all the x. Okay, all these x you square. The rest copy. So my calculation becomes 1 square times 15 over 35 plus 2 square times 10 over 35 plus 3 square times 6 over 35 plus 4 square times 3 over 35 and lastly 5 square times 1 over 35. So then this calculation, it will be 182 over 35. So once you have found these two values, variance x, it will be EX squared minus square of the EX. Then I will be getting 182 over 35 minus 2 squared. Okay, so at last, you will be getting 6 over 5. So make sure your variance is positive. Alright, so this is the solution for question 7C. Okay, so we have come to the end of the video. Thanks for watching. Please subscribe to the channel and recommend it to your friends. And also stay tuned for more upcoming videos. Thank you. Bye.